Dear friends, in this video, I'm starting a new topic, pricing analytics, some interesting problems. I will do a number of problems, and now I'm going to discuss problem number 1. Currently, you charge $5 for a razor and you sell 6 million razors. Assume that the variable cost to produce a razor is $2. If the price elasticity of demand for razors is 2 and the demand curve is linear, what price should you charge for razors? This is an interesting problem that has been adapted by me for discussion from Wayne Winston Marketing Analytics. And let me discuss my own methodology in this particular problem, and let us see how the solution emerges. Since the demand curve is linear, y equal to a minus bx I write, where y is equal to demand in million units and x is equal to unit price in dollar. A is equal to intercept and B is equal to slope. And you have a negative slope here. There is a negative sign because all of us know for all normal commodities, demand is inversely related to the price. In other words, if the price increases, demand decreases. Therefore, there is a negative sign here. Now, how do we determine A and B? Then only we can get the solution. We need to find out the values of A and B. What data do we have? The problem says the current demand is 6 million units for a price of $5. X is equal to 5. As you can see from the problem, which I read out in the previous slide. So there is one equation, A minus 5B equal to 6. This is based on the current demand. And then we have got the data, price elasticity is 2, which means if price increases by 1 percentage point, the demand decreases by 2 percentage point. So price increases by 1 percentage point from 5 to $5.05, from $5 to $5.05. The demand decreases by 2 percentage point from the current level of 6, which is equal to 5.88 million. From 6 million, it drops to 5.88 million. Now, if you solve the two equations, you get A is equal to 18, B is equal to 2.4. Hence, the demand equation y equal to 18 minus 2.4x. This is the first step. You need to find out the intercept and the slope. So we have found out, we have got the demand equation in full form. Now, let's proceed. Unit contribution is equal to price minus variable cost, which is equal to x minus 2. If x is the price, x minus 2 will be the contribution. X minus 2 will be the unit contribution because the variable cost is $2. It is given in the problem. For example, the current price, when you say is $5, it will be, the contribution per unit will be $3. Now, total contribution is given by TC is the symbol I use. X minus 2 is the unit contribution, which I multiply by the quantity demanded Y, which is 18 minus 2.4x. Upon simplification, this is equal to 22.8x minus 2.4x squared minus 36. Now, what should be the value of x that will maximize the total contribution? Go back to your calculus days. The first derivative, that is differentiate TC with respect to x, the first derivative must be found out and equated to 0. If we do that, dTC by dx equal to 22.8 minus 4.8x. The derivative of x is 1, so it is 22.8. The derivative of x squared is 2x. Multiplied by 2.4, it is 4.8. Therefore, 22.8 minus 4.8x is equal to 0. So x is equal to 22.8 divided by 4.8, which is equal to $4.75. So this is the price. And therefore, the demand is equal to 18 minus 2.4 multiplied by 4.75. This is equal to 6.6. That means the demand is equal to 6.6 million units. So what is the total contribution in dollars? Price is equal to 4.75. And therefore, I subtract the variable cost, 4.75 minus 2 multiplied by the demand, which is 6.6 million. I get 18.15. And therefore, the total contribution is equal to $18.15 million, which is the solution to the problem. A magnificent problem, thought-provoking, and absolute clarity, we can get it. Now, another interesting thing, if you are intuition-oriented, you apply a heuristic approach. First, you write all the equations, and then let's say you don't do calculus, simply find out a visual graphic. You get a beautiful graph in Excel, which you can do. So the demand is plotted on the y-axis, price is in the x-axis. Of course, convention in economics is price in the y-axis, but the demand is in the x-axis. But I have changed it for the purpose of ease of understanding. Demand is y-axis, price is this. And this is the demand curve. And then what happens is there is a jump here because from 3.5, if you make it 3.75, it will be a straight line. But there is a jump because the graph shows 3.5 to 4 and 4.25. So negative demand here, it goes. And the unit price is 4.75. The profit or the contribution is a nonlinear function. So you go and see 4.75, and I will show you in this form 4.75, 6.6 million, and the profit is $18.15 million. And therefore the price, demand is 6.6 million, and the total contribution is $18.15 million. Signed, sealed, and delivered this magnificent problem. I hope you have enjoyed this and got some insights. Thank you very much. We will see you in another video very soon.